Today I present my paper regarding study on water purifier applying direct cooling system. This present will be in this order. One is introduction, and the second experiment, and the third one the research, and the finally I make some conclusions. For the introduction, I wrote in this way, looking at the drinking water supply device used in Korea. It is largely divided in the absorption filtration type, nature filtration type, and reverse osmosis pressure drinking water supply device, and ion raising filter, and the UF whole hollow fiber membrane drinking water supply device according to the purification method. And one of the among those methods, absorption filtration, and the nature filtration of drinking water supply devices include activate carbon method, ion exchange raising method, or sterile filter method, which is good for the removing chlorine component and organic substances in water. But it has this advantage in that it cannot remove bacteria, which is not applicable at this point. Furthermore, the ion raising technology is a technology that separates water into HCD water and alkaline water using an electrolysis device, and has low bacteria remove performance. So an activated carbon filter and an UF hollow fiber membrane filter is required in the device. After the mid-1980s, a membrane-based drinking water supply device was first studied in Korea, and recently a reverse osmosis pressure drinking supply device and UF hollow fiber membrane drinking water supply device are the main types in Korea. The cooling method of water purifier is largely divided into two. There is a direct cooling method that cools water by installing an evaporator inside the water purifier, a cold water tank, and the indirect cooling methods that cools the water inside the reservoir by cooling the entire cold water container by placing the evaporator outside the cold water container. However, since the water is always stored in the cold water tank, it is necessary to clean the water bottle due to bacterial growth. In addition, the cooling water tank must operate the cooling system frequently, regardless of the use of drinking water, to maintain the constant temperature at all times. And unnecessary power required for standby is consumed. On the other hand, the direct water purifier cooling system has a lower continuous discharge rate compared to the storage type. In this study, by improving existing instantaneous cooling system, the cooling coil is directly in contact with the cold water pipe, so that the heat is directly transferred by the heat conduction method that occurs between the cooling coil and the cold water pipe, thereby contribute to the energy consumption. General device for tested performance water purifier with the instant cooling system is equipped by a water filter to purify water received. Hot water is supplied to drink water through the heater, and the cold water is composed of condenser and the expansion valve through a compressor. For this purpose, cooling coil is installed in the insulate cooling system to directly transfer the cooling drinking water supplies stainless pipe and the hot water. Here's the diameter of cooling coil, which is copper coil, and the stainless steel pipe, such 3 or 4 for supply cold water is 10 millimeter each, and the height is 70 centimeters small, 200 watts for cooling coil, and the low cold water was applied, and the 600 watts for heater for the hot water was applied to the water purifying system. The schematic diagram of the entire water purifier system and the cooling system is shown. Next graph. This is this is the experiment diagram of the water purifier system. Before explain the experimental method, first I did in this way. First, in order to secure water outflow performance at the cooled water and temperature of cooling system to 8 centigrade and sterilize for 10 hours, and then start out the cold water, increase the amount of cold water out from 1 liter to 10 liters at the time process. Cold water temperature change was measured. Secondly, in order to measure the hot water performance, the hot water temperature was set to 85%. Sterilized for 8 hours, then the heater operating time was measured while increase the amount of hot water from 1 to 10 liters. Third one is, in order to measure standby power consumption, temperature of a cooling system was set to 12 degree, and after only operating cooler and sterilizing for 8 hours, the cooler was stopped and the standby power consumption what was measured. This is shown previously, and this is for the 3D diagram for the direct contact system of cooling and water cooling system. This is final result for this research. This is showing the cold water quantity versus cold water temperature. Look at the this is x-axis represents cold water, y-axis represents cold water temperature. Starting water temperature was 14.7 degree, and the cooling system was maintained 8 degree until 75 minutes after operation, and the water discharge temperature gradually increased from the 9.5 minutes. After that, the time required was 30 minutes. And this is shown the cooler operating time. These figures show the operating time of cooling system. As the amount of cold export water increased based on the target cold export water volume of 10 liters. On average, the operating time for per liter of cold export water took 1 minute. In this figure, they show the hot water temperature. Hot water temperature at the water purifier is generally 85 degrees, and the hot water temperature was set to 85 degrees to measure the performance of water outflow. The starting water temperature was started at 14.7 degrees, and temperature increased from 2 liters at 85 degrees. The target hot water temperature was reached. This showed the collection of the elapsed time of the heater according to the amount of hot water. It took only 9 seconds to reach 10 liters of hot water at 85 degrees. And also, I tried to, this is a very important point from this research. To measure standby power and the standby power's ranges, as the temperature of the cooling system increased, it took 7.2 watts to maintain the cooling water temperature of 8 degrees and the 45 watts to maintain the cooling water temperature 12 degrees, which is target for the energy saving like this. Okay, finally, I'll make some conclusion on this issue. In this study, I like a conventional method of cooling purified water by installing a cooling coil on the outside of the cooling box and insert the pipe through which purified water passes to cool the water in the cooling box. In this study works only when drinking instant cooling system is applied. An instant cooling system was developed to increase the amount of cooling cold water output at 12 degrees, more than 3 times of 3 liters to 10 liters. Unlike the existing instant cooling system, the cooling coil with the refrigerant directly contacts the cooling water pipes to reduce standby power from 100 watts to 50 watts to maintain the existing cooling water tank, contributing to energy saving. To remove the unnecessary cooling water power, the concern about the occurrence of bacteria has been eliminated, making water bottle management easier. In addition, unlike the existing water purification system, which is equipped with the unnecessary cooling water tank, the system is to simplify, making it possible to manufacture a small water purifier. Thanks.